Hey everyone, welcome to Coding Vibes. This is the second part of Liskov Substitution Principle video where we are going to discuss a couple of things. One is we'll take some examples. One would be the example that we took in the previous video and we'll code it. Another example that we'll take to understand Liskov Substitution Principle in detail, right? And after it, we will go over the advantages of Liskov Substitution Principle, which is more or less very similar to what we have seen in our previous videos. Let's get started. In our previous video, we took an example of payment service where we had a method make payment, which was taking payment processor. And if we go over payment processor, it is a simple class which has a method process payment, right? And then we have couple of more classes which are extending payment processor. So one is our credit card payment. For now, I have a message which says that I'm processing a credit card type of payment, and similarly we have another payment method, PayPal payment method, which has a message saying I'm processing PayPal type of payment. If you see in context of Liskov substitution principle, our payment processor being the base class, right? So this would be the base class, right? And then PayPal payment processor being child class, credit card payment being another child class to payment processor. If we go to the main payment service, we have a make payment method which takes the parent class as a method parameter and a payment object, and then it calls the process method. So this process method would be called for a specific payment processors, right? So if we take example, we have initialized the payment service, we have initialized the credit card payment processor, and then I've created a payment of rupees 100, right? And then what I'm doing, payment service, then make payment. This is a child class to payment processor, right? And then I'm passing a payment. Similarly, another example is about creating a PayPal payment processor, and then I have created another payment of rupees 200, and then I'm doing same, make payment with another child class, right? So this is the example that we took in the last video. Let's take a different example from what we were talking in our previous videos, which were mostly around finance, like a bank account or something like that. I do have a use case in that example as well, but I wanted to discuss it in a little different way. So nowadays we have cars that can be fueled either via, let's say, petrol, diesel, or we can have electric cars as well, right? So let's go over the class that I have created. So I have created a vehicle class which takes a fuel type, right? And then it has a method called refuel, and for now I'm just saying refueling this fuel type vehicle, right? Now let's see if I create a car, right, and I pass on the fuel type, maybe either petrol or diesel. So this is fine, right? This car is either a petrol or diesel vehicle, so this looks okay. So what I have done while creating car, I have extended the vehicle class, the base class. Now we have another class, electric car, right? And over here we are saying fuel type being electric. Electric cars run with electricity, right? It's we don't need to fuel them, right? So it's a different mechanism. So if you see, now our child classes are not actually following Liskov substitution principle. So we cannot have an electric car, right, and then say refuel this car, right? So that's the problem. let's see how do we solve this. So refueling being a problem, right? So let's do this. The vehicle, we will remove the refueling part from here, right? And we'll have the basic property of vehicle. What we will do for refueling, let's have another interface. Let's say refuel, and this interface has a simple method refuel. Now what we can do, in our car class, the car class can have fuel type of its own. Now what we can do, we can implement the refuel. All right, so now all the cars that requires some sort of refueling, they can implement this refuel interface, right, along with the basic detail of vehicle. So we can always pass on the basic detail of vehicle from this constructor to the superclass, right? Now let's go to the electric car. This electric car, it does not require to implement the refuel interface, right? So it can have its own logic to charge the car. If you see now, our parent class, which is nothing but the vehicle, right, it would have the basic details, let's say number and then other details. This base class and then the child classes like car and electric car are following Liskov substitution principle. So the behavior remains same, right? If it is a car, it can have fuel type and then it can be refueled. But if it is a electric car, it can have some mechanism to charge it, and then that can be a separate thing specific to electric car. So these were a couple of examples that I wanted to discuss. Next, we will be looking into the benefits of Liskov substitution principle. So as I said in the start of the video, the most of the benefits of Liskov substitution principle are something that we already discussed in single responsibility principle and open close principle. I can give you a brief about them. So like maintainability, if we talk about maintainability, so as you know, right, all the related code would again go to separate classes, right? So it becomes easy to maintain that code base. So any new feature would again go into a new class, right? And hence maintainability would be better. Extensibility again, it's on similar lines, right? So if you have a base class, whenever you want to add a new feature or new feature, whenever you want to add a new feature, you'll extend this base class and write your new feature, right? The example that we had about payment service, so we had credit card payment, also PayPal payment. So Bitcoin payment can be extended from the payment processor, and we can always have the Bitcoin payment method or any other payment method. Reusability is again, the code is separated well, so we can always reuse it. One important advantage that I wanted to discuss is enforced contract. So what does that mean? So whenever you follow LSP, it ensures your subclasses adhere to the behavioral contract established by their superclass. So as you have seen in previous example, right, where vehicle class or vehicle interface would have a contract with all its subclasses. So that contract would remain consistent, right, making sure we don't get into some unexpected behavior, right? So initially when we were having vehicle class and then there was a fuel method, right, that all type of vehicle has to implement. So in case of electric vehicle, we were implementing fuel method, which was not relevant, and that's when we segregated this fuel into a separate interface, right? So this is very important. Whenever you follow LSP, the contract of the behavior would be enforced between the parent or superclass and the child's classes. So this is the major advantage that I wanted to discuss, and this would be the end of this video. Thanks for watching.